Right, everybody. Welcome to the NASEO Severe Summer Weather Energy Outlook 2023 webinar. While people are trickling in, I'll just give this a minute for people to join the audio. But we have a full agenda, so I'm going to get us started. So again, welcome to the NASEO Severe Summer Weather Energy Outlook 2023 webinar. My name is Kirsten Berkfuss. I'm Senior Managing Director at NASEO, the National Association of State Energy Officials, and I lead our electricity and energy security programs. And I'm very pleased to welcome you all to this event today. NASEO and the Energy Security Committee host this event annually in conjunction with our Winter Weather Outlook webinar in the fall to educate and help states and state energy offices in particular to prepare for energy security implications of extreme weather events in the summer, which include hurricanes, wildfires, severe storms, and drought, as well as the impact of economic and geopolitical considerations on the energy supply and demand. Before we begin, I would first like to thank the U.S. Department of Energy's Office of Cybersecurity, Emergency Security, and Energy Security and Emergency Response, CESER, for their support of the 2023 Severe Summer Weather Energy Outlook webinar, and their support overall for NASEO and the state energy offices and energy security planning and responding to energy emergencies. I would also like to give a special thanks to our speakers from the National Oceanic and Atmospheric Administration, the North American Electric Reliability Corporation, Citigroup, and the National Interagency Fire Coordination Center for their participation today. NASEO represents the governor-designated state energy office directors and their offices from each of the 56 states, territories, and the District of Columbia. NASEO members, the state energy offices, play a pivotal role in energy security as their governor-designated leads for energy within the states and state energy office directors. And for many of their states, the staff serve as the emergency support function 12, which is the energy lead, to provide technical expertise and facilitate response and restoration during energy emergencies. State energy offices have and continue to make significant resilience advancements by strengthening regional petroleum coordination and response, expanding their engagement with industry, both investor and consumer-owned utilities, and by crafting actionable state energy security plans to prepare their state for the various natural and man-made disasters that may arise. I would be remiss if I didn't mention the recent super typhoon Mawa that severely impacted Guam and the Commonwealth of the Northern Mariana Islands. And their respective energy offices are working in close coordination with DOE and other partners such as FEMA to restore electricity to the islands. And our thoughts are with them as they continue to the recovery and restoration effort. Before we begin, a couple of housekeeping items. This event is recorded. If you have any questions, please make sure to put them in the Q&A. We will have opportunities for posing those questions to the speakers after each of their remarks. And with that, I'm very pleased to now introduce Ben Bolton from the Tennessee Department of Environment and Conservation and the NASEO Energy Security Committee Chair, who is the moderator for today. Over to you, Ben.
All right, thanks very much, Kirsten, and appreciate those opening remarks as always from NASEO and for putting together this excellent panel that we have today. So I'm not going to take a lot of time other than to say that we always have wonderful speakers and appreciate several of them joining us back again for this annual panel that we do. It's a good way to get an outlook of and baseline agenda. So here's what we're going to be talking about today. We've already gotten the first two items off the agenda, but then we're going to have NOAA go over the hurricane outlook as well as severe storm outlook. Then we'll get a wildfire outlook for the summer. I think if all our brethren in the Northeast certainly have experienced a bit of the wildfire smoke that's been going on and causing, I heard a code purple in DC today. So our thoughts are certainly with y'all. It's even hazy all the way down here in Nashville today. As well from the wildfire smoke, but not nearly the impacts that it's having on the Northeast. So I think it's unfortunately all too timely that we hear about that. Then we'll hear from NERC on the summer reliability assessment and get an overview from them. Then, of course, Ed Morse, an old NASEO favorite, come back to from Citigroup to give us a little bit of the geopolitical and economic outlook. We're involving the energy sector. And then finally, but not least, batting cleanup for all of us is CESER, who we could not do any emergency response without. and certainly coordinate with them on a regular basis. And I'm glad to have them join us as well. So with that, we'll start with Matthew Rosenkrantz, who's the Climate Testbed Director of the Climate Prediction Center of NOAA, the National Oceanic and Atmospheric Administration. And with that, I will turn it over to him to lead us through the seasonal hurricane outlook. Thank you for joining us.
For sure. Hello, everyone. Glad to be back again. We just jump to the next slide because they do have a lot of slides and not that much time. So I want to talk about the seasonal hurricane outlooks that NOAA releases. We released them in May for the Atlantic, the East Pacific, the Central Pacific, and the West Pacific. West Pacific is a little delayed because that is hosted and led by WFO, the Weather Forecast Office in Guam, which has obviously had some challenging situations recently. And then in August, we will update the Atlantic outlook just before the peak of the Atlantic hurricane season. You can see that in the bottom left there, the Atlantic hurricane season really truly does peak August, September, October. That's about 92% of all tropical cyclone activity happens after August 1st, and even about 70% of all tropical cyclone activity in the Atlantic happens after August 20th. We don't update the Eastern Pacific outlook in August because that's kind of pretty far into the season, the peak of their season there, even though they are off to a slow start this year. If we update in August, that'd kind of be halfway through the season, and that would be cheating, so we don't want to do that. So next slide. I just wanted to let everyone review where these tropical storms mainly form. So in the upper left is July. You notice there's actually quite a bit of formation preference in the Gulf of Mexico and off the east coast of the US. And as we move into August, you start to get some formations deep into the tropics. And then September, in the kind of top middle, that's when you get most of your formations in the deep tropics, and then they move up and they have tracks that go up off the east coast and curving tracks there. But September is still your most popular month for tropical storm formations. It's the month of the most formations. And as we get to October, we still have some deep tropics formations, but you start to get back to where your formations are relatively more likely closer to the coast, moving into the Gulf of Mexico, off the coast of the east coast of the US. So there's kind of, it starts there, starts close to the coast, moves down deep tropics, and then comes back up. And that's tropical storms. Next slide. Hurricanes follow a very similar kind of pattern, although they have a little bit more, in October, they have a little bit more mass out towards the open ocean of the Atlantic. And in September, you'll notice that some of the storms form in the deep tropics as tropical storms, but then they become hurricanes more frequently when they get towards Bermuda. There's a little bit of an extension also into the northeast Gulf of Mexico and towards Louisiana there, where maybe they were something was a tropical storm down near Cuba, but then into the eastern Gulf of Mexico became a hurricane. So there's a little bit of a preference there, but it's still very small. There's only about 2 to 3 named storms forming the Gulf of Mexico in a given year, and the average is 14 for a year. So the bulk of your tropical storms and or hurricanes still form in the main development region, which is down in the tropics south of Cuba, Caribbean, and out into the tropical Atlantic, about 21 degrees north and south of that. So next slide. This is a graph of landfalls from 1900 to 2010. We're in the process of updating this through 2020. We do things like this kind of every 10 years. But it shows that southern Florida has the highest risk of landfalls. Then your next potential most popular place for landfalls, or most frequent place for landfalls, would be the Outer Banks of North Carolina. And then kind of an equal chances around a lot of parts of Houston, Galveston Bay there, and then also the southern part of Louisiana. Not very many landfalls, relatively very many landfalls in Georgia, kind of Jacksonville, then Florida, and down to the Space Coast. Relatively infrequent there. They do happen, but they are relatively infrequent. So just giving everyone a kind of general overall, this is the relative places where they've happened. And that's 110 years worth of data, so that's a decent sample size. Next slide. So the outlook for 2023, we have a 40% chance of a near normal season, 30% chance of above, 30% chance of below. That is one of our lower confidence outlooks that we have put out. And that is because we have we have a couple of competing factors this year. And I'll get into those in a little bit. So we have two things that'll compete, and depending on exactly when each one of them is winning out for a given week, could tip us towards a very active season, or could tip us towards a very below normal season. So named storms, our most likely range is 12 to 17 named storms, which is tropical storms and or subtropical storms. There was a subtropical storm in January. It lasted for about 36 hours. That is included in the 12 to 17. We had Tropical Storm Arlene that formed in June, so that would be in these numbers as well. 5 to 9 hurricanes and 1 to 4 major hurricanes, and our total energy for the year is likely to be 70 to 145% of normal. Normal range is 80 to 130%, so that forecast range is a little wider than normal range, reflective of the uncertainty, but it also straddles the normal range. So that's why our forecast here, the 40% chance of near normal, but we have quite a bit of spread and quite a bit of chances for it to go either above or below. Again, a less certain forecast this year. You see the numbers for 2022, 14 named storms, 8 hurricanes, and 2 major hurricanes. We missed the major hurricanes by 1. If we got the third one, it would have been in the range. And typically that would have pulled the ACE up another into our range as well of 110. So we produced 98% of normal for accumulated cyclone energy last year. So last year was almost spot on a normal year. 1 more hurricane, 1 less major hurricane, and almost everything was perfectly normal last year. Next slide. So if you're looking also at the Eastern Pacific, if you want to think about those storms that move on the Eastern Pacific can cause a lot of moisture surges into the Southwest U.S. And bring some heavy rains, especially after in September. After about September 15th, you can get a lot of moisture surges into the Southwest. Surges in the monsoon are typically related to tropical cyclone activity in the Eastern Pacific. So you can have different, very active rainfall patterns in the Southwest just because of tropical cyclone activity in the Eastern Pacific. And there they have a 55% chance of an above normal season. We are expecting 14 to 20 named storms, so that could imply 14 to 20 moisture surges into the Southwest, where you have your monsoon, and it'll be a very active portion of the monsoon. So if a tropical storm moves past the bottom of Baja California, typically about a week and a half later, you see a surge in moisture up in the U.S. on the Southwest. Sometimes it's the remnants of the storm itself. Sometimes it's just a moisture surge. Next slide. And this is just a graphic to show you kind of when those typically happen. Most of those happen after August 15th, but you really see a peak in them in September. Despite that, you have a lot of tropical cyclone activity in July. You can actually get most of these moisture feeds from these tropical cyclones and even remnant tropical cyclones moving into the Southwest. It's really a September phenomenon, maybe even early October a little bit. Next slide. So what did we look at for this outlook? And led us to us. Next slide. This slide is even out of date. It should say an El Nino advisory instead of ENSO neutral. The El Nino advisory came out at about 9 o'clock this morning, so we are officially in El Nino status. So Nino, the temperature that we measure typically is in Nino 3.4, and NOAA looks for that to be about 0.5 degrees centigrade. So that's a half a degree centigrade above normal in the sea surface temperatures, kind of in the East Central Atlantic, or East Central Pacific, sorry. So we can see that when we look in the kind of second box down from the top on the right-hand side, Nino 3.4, we are warm. We've been getting up to about 0.5. Last year, this time we were about minus 0.8. So we're just almost opposite of where we were last year at the same time. We are seeing some more coupling to the winds. You can see in the middle plot, the 850 millibar winds. Those are winds at about 4,000 to 6,000 feet above the ocean surface. Those are showing that the trade winds across the Western Pacific are quite reduced. And we even had pockets of reduced trade winds showing up in the Eastern and Central Pacific as well. Those have increased in the past week. So that's why we went with the advisory status as well. So those are just forecast to increase the wind anomalies, which is really saying decreased trade winds across the Pacific are likely. So we are in an El Nino now. So that's one factor. El Ninos typically reduce tropical cyclone activity in the Atlantic. So that's a key factor to keep in mind. Next slide. 93% chance of being in an El Nino during the peak of the hurricane season. So again, El Nino would favor decreased tropical storm activity in the Atlantic. Next slide. These are the factors that would increase tropical cyclone formation in the Atlantic. So this is the opposite. This would have the opposite impact. Looking on the left-hand side here, I'm looking at winds over the Atlantic. In the green box, that's showing reduced trade winds in the Atlantic. That's favorable for tropical cyclones because you have less wind shear if you have reduced trade winds. Also, looking on the right-hand side of this graphic, over top of Western Africa, I'm seeing the first signals of the West African monsoon start to really come alive. A strong West African monsoon would support more tropical cyclones and hurricanes in the Atlantic. So I've got these factors in the Atlantic supporting activity. I've got El Nino that says, no, we won't have activity. So that's my uncertainty, and that's why the forecast has the lower probabilities. Now, if El Nino wins out right when the Atlantic should be peaking, that may cap off and take off 2 or 3 storms right from the top of the potential of the season. If the Atlantic is winning right during September when the Atlantic should be active, and El Nino's impacts are kind of mitigated during that time, you can end up with a very active period and end up with an active season overall, just because of a short 2 or 3 week window where one of these two factors, these two titans, could win for a little bit. Next slide. So looking at wind shear, this is another reason for some of the uncertainty in the outlook. Our in-house NOAA climate model had some enhanced wind shear over the main development region in the Atlantic, which would be not favorable for tropical cyclones, but it has a lot of reduced wind shear outside of the MDR, where you can get some activity there. So that's kind of the white area that's extending from Florida to the east. So we may end up with some more activity there. When we include our partners from Canada and Geophysical Fluids Laboratory and run about 100 model simulations of the summer, we get a little bit less wind shear in the main development region, a little bit more over the southeast, but still generally that same pattern where the wind shear is decently strong to the south, and you have this kind of corridor at the northern edge of the main development region extending towards Cuba, where you could get it would be much more favorable for tropical cyclone formation in those regions. Next slide. So our summary is Atlantic is still looking at a near normal season just because of the competition of the warm and supportive Atlantic versus the El Nino. And the Eastern Pacific, when El Ninos happen there, they are much more active. They end up with more activity during those years. Next slide. I want to jump into a little bit of the drought outlook this summer. Keep going. So drought monitor, last year when we did this talk, drought was very prevalent across the Western US. When I grabbed the drought monitor last week, the most intense drought was in Nebraska and Kansas, and even since then they've gotten some rain. There was a bit of a flash drought going on now towards the Corn Belt, lower Great Lakes. So that's something to keep an eye out for. Next slide. Drought outlook did show some of that improvement, and this is the drought outlook for the summer. We should continue to see more improvement of the drought conditions in the plains, some improvement in the drought conditions in Florida, but really does look like drought conditions in New Mexico and Texas and the Northwest are likely to hold on through the summer. Next slide. All right, this is our summer outlook that is currently out right now. Above normal temperatures are favored from the northwest across the southwest, southeast, and then up to the northeast, with equal chances in the northern plains and the Great Lakes. We are expecting below normal precipitation, for at least for the first part of the monsoon as well across New Mexico and eastern Arizona. That could mean a shift in the monsoon to the west across California, Arizona, and also a push to the north, which would be more traditional during an El Nino. You end up with a push to the north, so you end up with a more active monsoon in Nevada and Utah. Next slide. So it's seasonal, and then this is what we have for week 2. This is a couple days old because I chopped the slides then, but there was some flooding concerns out west with the because they had such a high snowpack, and as they warm up, you're going to melt off the snowpack. There's a chance for that flash drought to become a little bit more intensified across the Great Lakes. That's what that yellow is there, and we're seeing some signs for excessive heat, which is really a very high heat index across the west, I guess the Western Gulf and into the lower Mississippi Valley. So that's all I had.
All right, thank you, Mr. Rosenkrantz. And with that, if we will stop here for a second and see if anybody's got a quick question. And that I know that's a quick outlook and could go into much more detail that would be fascinating to hear about. But that does give us a great overview and breaking news about El Nino. So certainly glad to hear that. If there's anybody has a question, please put it in the chat. And we'll give it just a second while everyone's forming their questions and see if anyone's got one. All right, I'm not seeing any at the moment. So thank you very much for the presentation. And now we will move into Matthew Elliott, also from NOAA, who's from the Storm Prediction Center, is going to talk about just that.
Great, thanks so much, and it's great to be here, and thanks for having me. So yeah, I just wanted to start off by showing, this is our website here on the left. Hopefully many of you are familiar with it, but it's really the best place to grab severe weather information, especially forecast severe weather information. You can just get there by www.spc.noaa.gov. And this is how it looked like on one of our biggest events in the past several years. This is from March 31st of 2023, just a couple of months ago, where we had a high risk, level 5 of 5 across 2 areas you can see there on the map. So it's really the best place to get information from us. And you can see here a peek into our forecast operations. We have 22 full-time forecasters working here on shifts of 5 to 6 people, rotating shifts 24/7. And you get an idea of what it looks like in our operations area. It's always good to see what it might look like. Next slide, please. So today I'm going to first start off by just talking about the hazards associated with severe thunderstorms, their climatology behind them, and then talk a little bit how to interpret our outlooks that might help aid in your decision making. So if you just click the button again. So what goes into the severe thunderstorm definition? Well, of course, tornadoes are a big part of severe thunderstorms. Click, please. Hail, current criteria for hail is at least 1 inch in diameter. It used to be 3/4 of an inch up until 2009. Next, please. And then thunderstorm wind gusts exceeding 58 miles per hour. Next, please. So one might wonder, what about lightning? Is lightning a part of the definition? Well, next, please. It turns out lightning is not part of the definition. Even though lightning does, there's about 50 to 60 fatalities per year associated with lightning and around $1 billion in insurance losses, it is not a part of the definition. So certainly lightning is a significant hazard from severe thunderstorms, but it is not something that is used as part of the criteria from the National Weather Service to issue a severe thunderstorm or a tornado warning. Next, please. There's also significant severe thunderstorms. And really, when we're talking about impacts to property, to life, we're talking about significant severe thunderstorms generally. And that's for thunderstorms with EF2 or greater tornadoes, 2+ inch diameter hail, and hurricane force winds are greater. So these are really the storms that are producing the most impacts to society. Next, please. So let's jump into each of these hazards a little bit more and talk about the climatology for each of them. Next, please. I should say real quickly too, flash flooding is the #1 thunderstorm hazard for fatalities, with around 90 fatalities per year for flash flooding. I won't be talking about flash flooding here, but just wanted to mention that. So in terms of lightning climatology, not too surprising. You see here, I got a map looping of the climatology from January through December. Expecting near the Gulf Shore, kind of the greatest activity throughout most of the year. And then as it builds through spring and into the summertime, the activity shifts more into the central part of the United States. Especially during the summertime, activity is generally located across portions of the southern central plains and the northern plains, and then across this belt across portions of Illinois, Indiana, Ohio, and into the portions of the mid-Atlantic and the Northeast. And of course, you'll see other areas like the terrain in the West, especially in portions of Colorado, in portions of the West, where terrain is really driving thunderstorm activity nearly every day. And I'll show the forecast risk that we see nearly every day during the summertime across these areas. And so we have a viewer available on our website. There's a link right there, a QR code. And you can click in on your location. You can pull up time series maps for when is lightning is most likely for my location, based off the time of day, based off the time of year. It can be really helpful in decision making and planning for future events and for future just kind of understanding of how lightning climatology might play a role in your events. Go ahead, next slide, please. And so for thunderstorm wind gusts, of course, are a significant impact to society. On the left there, I'm just kind of showing a microburst developing on the top image and then coming to the surface on the bottom image, really producing some localized damage in an area. And of course, lots of tree damage, lots of property damage associated with wind gusts. And really it doesn't take much wind at all to cause significant damage to mobile homes, manufactured homes. And it's really people in those types of structures really need to take shelter in a more sturdy structures in any severe thunderstorm, because really not just tornadoes, but winds associated, straight line winds from thunderstorms could also produce winds that are strong enough to topple mobile homes and other structures like those. And next slide, please. Of course, the strongest, most widespread damage with wind is associated with derechos. And these are typically fast-moving thunderstorm complexes, widespread swaths of significant wind. So several hurricane force wind gusts across its path. And typically, unfortunately, because these are quite impactful, they are quite variable predictability-wise. And so oftentimes you might not see them coming well in advance into the future. So tornado outbreaks, those are usually pretty well forecasted, often several days in advance, but derechos can often show up the day of the event, and lots of things come together in the right place at the right time, and you can get very impactful events. So for example, that August 10th, 2020 derecho across portions of Iowa, it was the costliest thunderstorm disaster in United States history. And really the morning before, just a few hours, we didn't, you don't know that you're going to see the costliest disaster in the United States history. Certainly you can pivot to there, but those are very hard things to forecast, and they can stretch local response efforts because of the widespread nature. Lots of power outages, lots of damage. It's very difficult to get resources out in those situations. And then they're often followed by intense heat during the summer. So you get power outages and heat, and those are not good combinations for society. I would say that it was $11.2 billion of damages for the derecho in 2020, traveled 770 miles, and there were hundreds of thousands of people without power for days to several weeks as well. Next slide, please. So here's just kind of the climatology of wind. And so it's similar to what you saw for the lightning, but I think what you really want to key in here is as we get to the summertime, especially, we're really focusing in on the primary areas of portions of the central plains up into the northern plains, and I'll let it loop through here again. And then as we kind of stretch eastward into portions of kind of the Midwest and upper Midwest, and then portions of the mid-Atlantic and the Southeast. Of course, during the summertime, there's lots of pulse, you know, kind of marginally severe storms that, you know, create wind damage across much of the East Coast. And so you have lots of wind, lots of trees and lots of ability to create damage from thunderstorm wind gusts. So we do see lots of reports in the East, especially during the summertime. That's the kind of the key time for portions of the Eastern United States. And these maps are also available on our website. You can click there on the link or use the QR code. And we are planning on updating this pretty soon as well, up to 2022. Next slide, please. So what about large hail? Certainly large hail really becomes most impactful as we get above the 2-inch and greater size. So you can get certainly you're coming through roofs as it gets bigger, like significant damage to property, cars, you know, wind-driven hail can be a significant challenge. Typically about $1 billion, 1 billion with a B, in crop and property damages per year. So it certainly can be quite impactful. And I've flipped to the next slide, see how it is climatology-wise. It's a similar pattern, but I will point out the difference with the wind here is it's really focusing in much more in the plains. Large hail is much less common in the Eastern United States. Certainly you can get, you know, large hail in some events, but it's more common in the plain states, especially the Central Plains and the Northern Plains in the summertime months. Again, links available here for this as well. The next slide, please. Of course, tornadoes get a lot of attention. They're singular events. We get about 1,200 or so tornadoes per year across the United States, and about $1.4 billion in damages and 70 fatalities on average or so. Next slide. Somewhat similar appearance here to the climatology, though I think the wintertime one, which we're not focused on here, certainly the wintertime, you see a lot more focused activity on the southeast part of the United States. We saw this year, actually, this year was above normal, but you see it in the climatology also here, you see right there on the map. But as you get into the summertime, you really see a similar pattern to the other maps. Really, it's focusing in on portions of here you go here, right in the summer now, portions of the Central Plains and the Northern Plains briefly, before things really start to die down into August and things, especially into September and October, and really shift back into that second season across portions of the Southeast into the fall months as well. Again, available on the website. And just lastly here, the next slide, I just want to end up here talking about some of our forecasts. Next slide. So we have a day one outlook, and that's really the best place to see forecast information for today. We have days 1 through 8, but I'm just going to talk about day one here. We've been doing day one outlook since 1955, so quite a long time, lots of experience doing that. And the categorical outlook is probably what you're most familiar with. Though I will say, if you want to get the most information and look in depth into the outlook, the individual probabilities for the hazards is really where you're going to find the best information. That's the science really behind the outlook. So the tornado probabilities, the severe hail probability, and the wind probability. Because you can also see the chance of the significant potential. Is there potential of EF2 or greater tornadoes, 2+ inch hail, or 65 or greater, or 75 mile per hour winds or greater? Because those are what's really causing the impacts, again, to you and to society. So looking at those individual hazards will really give you a lot more information about the outlooks. We do them 5 times a day on day one. So check back regularly because there might be updates throughout the day. So I'm going to talk a little bit how to interpret these products. So just quickly, next slide. So if you're just in that general thunderstorm category, that's really kind of a typical, you know, it's a typical chance of having a thunderstorm potential. It's a 10% chance or greater chance of a thunderstorm in your area. You're really not expecting organized severe thunderstorms. Certainly a pulse storm could develop and you could have some gusty winds, some small hail. You know, it could gust near severe limits, but not expecting, you know, widespread severe, certainly not expecting it to become organized or last very long at all. And of course, lightning, it could produce lightning, and that's certainly a danger as well. Next, please. The lowest, I was going to show this too. So this is kind of the forecast of the number of days. Like how often do we issue the thunderstorm forecast where you have at least a 10% chance of thunder over your area? This is the last 6 years. So you get an idea of the variability per year. I'm going to go to the bottom right one just to kind of pick one. And 2017, And just to kind of show, you see most things you expect. Florida obviously gets a lot of days with the chance for thunderstorms, but just pointing out like the West, terrain, there's a lot of days where there's no chance of thunder in the West, in the Sierras, for example. So really, it's all happening in the summertime. And so really in the summer in Colorado and portions of the terrain in the West, where you have higher terrain, it's almost every day where you're having a chance of thunderstorms. And really, that's why you don't want to be out hiking in the higher terrain in the West, because you really do have a chance of thunderstorm almost every day across those portions of the area. But like you expect, as you go from the Gulf and you go further north, your numbers of days just decrease because of your potential of days are just fewer available days to have thunderstorms as you get further north latitude. Next slide, please. So let's kind of jump into our severe categories. A marginal is the baseline level. It's the lowest level we have. Just a few severe storms possible. Next slide. Kind of just showing a distribution of these. I think that the key things here are to point out two main areas: Mid-Atlantic, especially that kind of the belt across portions of the Midwest, where you get a lot of wind storms, especially in the summertime, and then of course the plains, where you have a lot of hail and tornado potential, especially in the springtime, and then moving into the central and northern plains during the summertime. You see it shows up very well in these graphics. Next slide. Slight risk is really, I think, the first category where you start thinking about like watches and really more organized severe weather. And so if you go to the next slide, where do we see these typically? Number of days per year. And it's really kind of a similar story to what we saw before. So, Mid-Atlantic, summertime, down along the southeast, kind of the eastern seaboard. And then, of course, portions of the Midwest during the summer and the central and northern plains during the summertime. Next slide, please. Level 3 is an enhanced. That's kind of where we're starting to talk about significant severe potential. So that's the impacts to society become even more. So if we go to the next slide, where do we typically see these enhanced risks? Well, they become fewer, right? Fewer of these per year, kind of scattered across the country. And each year, you're not going to typically have any significant patterns. Some years you get more in some other areas, but really we're focusing in on these kind of east of the Rockies for this potential of these enhanced severe storms. Next slide. Of course, moderate is the next level, and we're talking about regional outbreak potential of severe storm potential. So numerous severe storms with several significant severe storms possible. So kind of where do we issue those? Next slide. Certainly those are even fewer and far between. Certainly lots across the southeast, that's kind of the typical time frame in the winter time. And as we get toward the summertime, the wind storms, derechos can trigger moderate risks. Large hail, things like that typically don't, but either it's wind or tornadoes that are triggering these types of moderate risks are higher. And then lastly is a high risk. And high risks are really, next slide, reserved for these significant large-scale outbreaks, tornado outbreaks, or a derecho, a significant derecho like the August 2020, if you could forecast that kind of event. So several significant severe storms possible. And if you go to the next slide, we don't issue these very often. Some years we don't issue any of them. And so really it's reserved for the worst of the worst situation. And we issued one earlier this year on March 31st of this year. So if you see those, that certainly means that you're expecting a significant day to occur, but really enhanced and greater across any part of the country, really starting to trigger things in your mind that the potential for significant severe weather is starting to increase. And with that, I think that's my last slide. I'll take any questions.
Sure. Thank you so much for that presentation, Mr. Elliott. And I do have one question that's in the chat. It's Ann Weiss, probably, said that what was the derecho that you were talking about that caused $11.2 million in damages? Does that have a name? That storm have a name?
Yeah,
Derechos usually get names? I didn't know that.
Well, that one, since it really impacted Iowa, it's actually called the Iowa derecho, since
Okay.
Iowa was really the epicenter of the derecho. They typically sometimes do, like the Mid-Atlantic derecho. It's called the Mid-Atlantic derecho. It's famous. Sometimes they do if they have like an easy way to name it, but not always, certainly.
I got you. So they get one more named after the fact, based on the damage it inflicts. I know we had one
Correct.
hit Nashville a few years ago, and I still remember it quite well because I didn't have power at my own house for days there. But the enhanced, a good thing that I'll add with enhanced is in our state, typically I feel like when we get an enhanced warning, that seems like that's not a direct one-on-one trigger for monitoring, but that's usually the point that we start paying attention more, and certainly we'll have more calls with our local National Weather Service, and the state meteorologist keeps a better eye on things. So if anyone else has another question, please put it in the chat. Thank you very much. That's a good awareness, because all of those things end up impacting us from time to time, or if they start in one state, we'll feel the impact and try to provide aid to the ones next to us. And if you are ever wondering about that too, you can call and talk to your local National Weather Service office as well. Those are always a good way to get the most current. And a lot of times they're even arrange with you to do products for exercises, or also maybe special forecasts if you need those as well. And really appreciate all the work that y'all do for us. So I'm not seeing any other questions in the chat at the moment, and hopefully, Ann, that got your answer for you. And with that, I will turn it over next to Nick Nosler. He's a meteorologist with the National Interagency Coordination Center at the National Interagency Fire Center. It's like most government titles, we all have lots of offices inside another thing and another one, but I always enjoy those. And with that, I'll turn it over to Nicholas. Nick, thanks so much for being here.
Appreciate it, Ben. Yes, I'm Nick Nosler, one of the 2 predictive services meteorologists here at the National Interagency Coordination Center, which is on the National Interagency Fire Center campus in Boise, Idaho. Next slide, please. So what is predictive services? We were established over 20 years ago. We are not just meteorologists like myself. We are also intel coordinators and officers and fire analysts. And so we look at a number of things. It's kind of the tripod of predictive services. And our main goal is providing decision support for fire management in the national coordination system. Each one of the different colored geographic areas that you see there on the right-hand part of your screen have GACs in them, or Geographic Area Coordination Center. As you guys know, government loves their acronyms as well. I'll try to explain each one before I say it. But we have 10 GACs located across the entire United States. And then here at NIC is the National Center. So 11 total predictive services unit. And each one of the units issue their forecasts independently, but obviously a lot of collaboration and coordination occurs. The GAC level information is integrated into national level outlooks, and we use this, if not daily, for sure weekly. And we get together with daily calls, and at worst, at least twice a month to coordinate and collaborate on a number of issues. Meteorologists handle fire weather. The fire analysts handle the fuels and fire behavior forecasts, and the intel coordinators and officers handle where the fire's at, how many acres are burning, what sort of resources do we have on them, what sort of resources do we still have available. So a lot of the intelligence gathering that is necessary to help us kind of frame and make decisions within fire management. Next slide, please. So I'm mostly here to talk to you guys about the monthly seasonal outlooks that we put out on the 1st of every month. And yes, how is this sausage made? It is a lot of objective analysis, but there is a little bit of art to it, just like any sort of forecast. We look at a lot of data, especially in the winter and spring. We look at snowpack, and then recent precipitation is we're looking at that year round. We look at drought, we look at soil moisture, we look at fuel loading. So how many fuels are they? Are they continuous? Is it above normal? Is it below normal? Is it more of the fine fuels like grasses, or a little bit of the heavier fuels into the shrubs? The phenology, what part of the growing cycle are we? Is it cured? Is it greening? Is it leaf on or leaf drop, especially if you get further back east, in the moisture content. And then we also look at fire season timing. So it's really complicated to put all of this together, and we're only part of the way there when we make our monthly seasonal outlook. We also look at the weather and climate outlooks. We work closely with our partners over in NOAA, especially the Climate Prediction Center. We also have some in-house expertise, and we look at all of the model guidance for days out to months out to see what it looks like. As Matt said earlier, we are now officially in El Nino, so one of my slides here in a little bit is going to be a little bit out of date, but that's okay. But ENSO, the Madden-Julian oscillation, which actually played a major role in our winter and spring out west, and a number of other oscillations or large-scale teleconnection patterns we look at. We put all of this together, and then we say, is this going to be above or below normal significant fire potential? And how we gauge that is we look at past significant fires or large fires across the United States and say, all right, is the potential there that we're going to see more fire than we typically do at this time of year for this location, near normal, or perhaps even below normal? Next slide, please. So let's get into this outlook. One of the things that we're keeping a real close eye on is the rapid snow melt in the northern portions of the West. There's been rapid snow melt since late April, and the curve going down in terms of the amount of snowpack has been steeper than normal. And in some areas, we have record to near record low snow water equivalent or snowpack values. Next slide, please. So this is snow water equivalent for the upper Missouri. The black line is what happened since last fall. You can see really good above average, the average is there in the green, and then late April hit and we just tanked. And now we're pretty much near record low values for this time of year, and many areas are snow free. Next slide, please. For the upper Columbia Basin, you can see they tracked pretty near normal throughout most of the fall and winter and even into the spring, and then late April happened, and then once again down to near record low values. Next slide, please. And finally, for the Kootenai, we did have new record low values here, pretty much no snowpack left as of a week or two ago. And because of this matters. As the snow stays on the fuels longer, it delays green up, and then it delays the curing after green up, which means you can shorten the window for fire season. As you get starting later in the summer, the sun angle doesn't become as high. And also as you get more into September and even sometimes late summer, you can start to have those fall troughs come and provide the cooler air and more of the precipitation. So if you have snow that stays longer, it really shortens the window that you can have fire season, but if it comes off sooner, you really extend that fire season, or at least have the potential to. Next slide, please. So the U.S. Drought Monitor, this is from last week. We've seen quite a bit of improvement this winter and spring across much of the Western United States. Also, some areas have increased in abnormally dry categories or even moderate drought in parts of the Pacific Northwest and Northern Rockies. Do have some short-term abnormally dry to drought conditions in the Great Lakes into the Mid-Atlantic and Midwest as well. And while we still have extreme to exceptional drought in a good part of the southern and central plains, they have seen some relief recently, and quite a bit of rain has fallen in the Rockies and onto the high plains as well. So some areas that had long-term extreme exceptional drought have improved quite a bit in the last month or so. Next slide, please. So El Nino or La Nina, we just had a 3-year triple dip La Nina. We did have a very strong and active winter with the spring and through the spring with the Madden-Julian oscillation, which helped bring the well above normal precipitation across the Western United States, and the record snowfall and snowpack that you saw in parts of the Sierra and into Utah as well. We're not in an El Nino watch, just like Matt's slide. Mine's a little out of date. And we are in an El Nino advisory. We do have El Nino conditions in the equatorial Pacific. And so we did have a rapid transition to an El Nino, not a chance of it. And it looks like we will continue to have El Nino through winter and into spring of next year. And I will say we are starting to see some El Nino-esque influence on the large scale patterns and weather patterns as Matt referenced earlier. Next slide, please. So the Climate Prediction Center June temperature and precipitation outlooks. We are looking at below normal temperatures for the Southwest, but they are likely to have some drier periods and some increased winds with the troughing kind of staying off the California coast or Baja California. And so that could dry them out, but they at least won't have the heat waves. As Matt mentioned, a lot of that moisture is going to move into more of the central and northern Intermountain West and across much of the Rockies. And it looks like the high plains as well, with continued chances of showers and thunderstorms in those areas. But we'll have above normal temperatures across the northern tier of the CONUS, especially in parts of the Pacific Northwest, into the northern Rockies, and also even into the northern plains and western Great Lakes. You can see the below normal precipitation also likely for much of the Great Lakes as well. Next slide, please. Looking at the July through September outlook from CPC, you can see the above normal temperatures likely for much of the western United States and through the south and on the East Coast. But we're also likely to have below normal precipitation in parts of the Pacific Northwest into the northern Rockies. Some of those areas, like I said, we've seen the rapid snow melt and do have the concern going forward for perhaps an extended window for above normal significant fire potential. Excuse me. And we are looking like a below normal monsoon for the core area there in the Southwest and kind of the broader Four Corners region, but do have the possibility of some above normal chances of precipitation there, more in kind of the western and central and perhaps northern Great Basin and into the Colorado Rockies as well, but a little less certain of that. Next slide, please. So moving on to our fire potential outlook, one thing with this, red does mean above normal significant fire potential, green means below normal, and the white is near normal. I want to say just because it is not red does not mean that those areas cannot have fires. It is just what is typical for this time of year, and do we think there's going to be above normal or below normal or even near normal significant fire potential. The reason why I always stress potential and not activity is there's a lot of uncertainty that go into these forecasts. You saw the data that we analyzed, and that can lead to potential. What are the fuels doing? How much are there of the fuels? How dry are they? What is typical for this time of year? And then that's one part of it. The next part of it is, what is the weather and climate going to look like? We have decent ideas for the most part on how the climate we think is going to unfold. However, singular or even a series of weather events can completely change a season. And so when you have above normal potential, significant fire potential, that is, you still need critical fire weather patterns to realize that. Whether it's a heat wave followed by lightning, followed by dry and windy conditions, or just a heat wave followed by dry and windy conditions. Those critical fire weather events, especially like we saw, almost seemed like a routine basis in 2020 and 2021, really made those fire seasons exceptional. Last year, we did have some areas with potential, but we didn't quite have the critical fire weather patterns emerge to realize that potential. Having said that, I'll actually start talking about the June outlook. Right now, kind of our greatest area of concern is there in the Great Lakes. They're setting some all-time record high fire danger indices in parts of Michigan right now. Michigan does look like they'll get some short-term relief here in the next handful of days or week, but it looks overall that they will stay in a relatively dry pattern and a relatively warm pattern. Much of northern Wisconsin and into Minnesota is likely to stay dry for the next couple of weeks. So we are anticipating some increased activity along with this above normal potential. Above normal fuel loading in parts of the inland Northwest there in central and eastern Washington, excuse me, into central Oregon. And that is starting to cure out with some warmer and drier temperature, warmer and drier weather. We are anticipating some above normal potential. Good news is that much of the California mountains and the northern parts of in higher elevations of the Southwest into Utah, due to that massive amount of snowfall and snowpack, are likely to have below normal potential in June. In Alaska, most of that red is somewhat conditional and likely to enter the fold later this month. Next slide, please. Moving on to July, you can still see that potential for Alaska. There is some correlation between an El Nino onset and some drying conditions coincident with kind of the peak summer up in Alaska. And so we are, that is a little bit more of a forecast and not as maybe confident in some of the other areas. but we did want to note that because there has been a historical correlation with above normal significant fire potential and the conditions that we are seeing and likely to see in the next 4 to 8 weeks. The above normal potential will expand throughout much of Washington in central and eastern or southeastern Oregon, and also into northwestern Nevada and southwest Idaho. We do have above normal fuel loading with the grasses and parts of the Great Basin and rangelands in those areas. And so that is likely to see some above normal potential because you do have the fuel to burn this year. Some of the timbered areas up in Washington, the Idaho Panhandle and Northwest Montana, with that rapid snow melt, are likely to see some earlier than normal fire activity. And the Great Lakes and even into parts of the Northeast are likely to continue to have above normal potential through July. Next slide, please. August, pretty similar story, a slight expansion in the above normal in parts of northern Idaho and western Montana, but continued above normal potential across the same areas as we saw in July. Do you see a reduction in below normal potential, now mostly confined to the Sierra and parts of the Sierra front, with the rest of California likely to have near normal fire potential. One thing I will note is that due to the perhaps weaker than normal monsoon in parts of the Southwest, we are keeping an eye on to perhaps have above normal potential in areas of Arizona and New Mexico if that comes to fruition. Next slide, please. And finally, in September, the last month of our four-month outlook, continued above normal potential there in Washington, parts of north central Oregon, into northern Idaho and northwest Montana. But we are thinking that the above normal potential will likely be done in parts of the Great Lakes and Northeast sometime in September, and still looks like a quiet fire season, although I probably just jinxed it for much of the southern and high Sierra. Next slide, please. So overall, kind of wrapping this up, record snowfall and snowpack in the Sierra and Utah will kind of delay their fire season and lead to below normal potential into July. In the Southwest is forecast to have below normal fire potential through June, but we are monitoring trends in the Southwest into the Southern Great Basin and Western Slope and forecast for a weak monsoon verify. Are keeping a close eye on the Great Lakes and into parts of the Northeast over the next 2 to 3 months. Like I said, some of those areas are having record dry fuels, record high fire danger right now. And most of the outlooks show normal to below normal precipitation and normal to above normal temperatures, which will likely keep that potential in there for at least through July and probably August. Above normal rangeland fire potential there in parts of the inland Northwest and into the Northwest Great Basin, also coincident to where we have above normal fuel loading and some of the drier and warmer climate forecasts. Next slide, please. The timbered areas and even some of the higher elevations in Washington into northern Idaho and northwest Montana will have above normal significant fire potential through the summer and perhaps even into early fall, especially if El Nino and the response to it is typical. We are monitoring Alaska for late June and July for perhaps above normal significant fire potential in eastern parts of the state, but we are not as confident as that as say we are maybe in the Northwest, Northern Rockies and Great Lakes states forecasts. As always, these forecasts are relative to normal and they are for potential. We do need those critical fire weather events to realize any of that potential, which is very difficult to near impossible to predict more than days in advance and especially weeks to months in advance. I believe that's the end of my presentation. I can take any questions.
All right, thank you, Nick, for that excellent summary. And I appreciate the last bullet, especially that saying this is potential and not necessarily actual or forecast. You know, there's the climate trends in meteorology, and then there's the sort of weather trends. And with fire prediction, it's no different in that respect. And so I think that's an important point for people to understand that while certainly looks like a better season overall, that still depends on a whole lot of factors that can change very swiftly. I'm curious, because it's such a relevant and in the news right now, when do we think the wildfires in Canada are probably going to die down, or how is that going to look? I would be remiss to not comment on what's a hot topic in the news right now.
Yeah, we were talking about this today because obviously we have sent a number of resources up to Canada to help with their wildfires, and they want to know, is this going to continue? In the near term, it is going to continue, unfortunately. There'll be some areas will get some relief here in the next couple of weeks, but due to the massive amount of fire that they have on the ground and how dry their fuels are and the type of those fuels that don't just, an inch of rain isn't going to put it out. They're used to inches or feet of rain in some of these areas. So it is looking like they will stay busy at least for the next month. And there's potential that at least parts of the areas that are busy now will stay busy through summer.
Thank you. And that's real important because that will still continue to impact air quality in the US as it tends to drift downward. And if the jet stream continues to misbehave as it has been.
And one thing I would add, if talking about the smoke, we don't forecast smoke, but obviously it is a huge impact, not only to firefighting operations, but to the public. And so there's always going to be smoke. If you're in the Western United States, people back east don't get it quite as often as we do, but it is one thing to keep note. And also with these outlooks, they are intended for fire management to make resource allocation decisions. And so, yes, there is some application to the general public or to energy companies or to other government entities. But, I would just say use caution and make sure you understand exactly what the colors on the map mean, as it can get misconstrued pretty easily.
Thank you for that very much. And if there are any other questions, I'll remind folks to put them in the chat. And if there aren't any others, thank you very much for the talk and the summary as well. It looks like maybe it won't be. I do have one more because it's so curious. Why do we see so much of that in the more upper latitudes and the lower? Because I'm a southerner, so I'm going, is it all the humidity that we have here that helps things? Is that why? Or why is most of the wildfire risk usually seen in the north, in the more northern latitudes?
Hey, that's a good question. I wouldn't say that's always the case. However, if you're from the south or the southeast, they are very active with prescribed burning, and so there's a lot of fires all year round, it seems like, and that can help mitigate some of the fire seasons. However, as you mentioned, your climate helps make prescribed fire a little bit easier in some respects due to the humidity and the relative frequency that you guys get precipitation. And so, it's a little bit of a chicken and the egg. We need more prescribed fire, but you need the climate to be able to do prescribed fire safely. And some areas are just more conducive for that than others.
And it doesn't mean that we don't have wildfires. We just don't seem to have the frequency, I think, that other areas of the country have down here in the South. But don't seem to be any other questions. So thank you, Nick. Appreciate that very much. And we will move on to our next speaker, also from the same Interagency Coordination Center and the National Interagency Fire Center. It's Jen Wallman, who's going to talk to us about also the factors impacting wildfires and some implications on energy security.
Hey, Ben, it was, I think that's a little perhaps misunderstanding. Yeah, because it was Jim we weren't sure who was going to fill in for this talk, and so both Jim and I were listed. He just was across the hallway. He's like, "Wait, am I supposed to talk?" So no, it's it's just for me, and I think we go on to the next speaker after that.
Yeah, that's totally fine. Okay, thank you. Then let's well, thank you, Jim, listening for there and for helping, I'm sure, prepare the slides and put stuff together for us, and appreciate y'all doing that. So let's move on to next is going to be John from NERC, and he is the director of the Reliability Assessment and System Analyst for the North American Electric Reliability Corporation, or NERC, and we'll let him talk to us about their summer reliability assessment. Always an important thing, that prediction that comes out each year and helps us get overall awareness of sort of electricity and what we think it's going to be like for the summer.
Great. Thanks, Ben. Great to be with everyone today. And I think this is a great transition as we're talking about weather. As we transition to talking about electricity, weather is probably the most influential factor in operating a bulk power system. And so power plants, substations, transmission systems are all exposed to the elements year-round, day in, day out. Weather affects everything from electricity demand to forcing generation offline. It can wreak havoc on our fuel systems, natural gas systems. We're seeing are more prone to disruption during extreme and prolonged cold weather. And of course, our emerging renewable fleet is fully dependent on how sunny or how windy it is. And so a really important piece to all this is that the electricity grid, we have to constantly balance supply and demand. We really don't have large-scale storage solutions. And so as we really transition our resource mix from predominantly coal, nuclear, natural gas, and move to more renewable energy, we need to ensure that we build a system to maintain, build and maintain a system that's reliable and resilient, even on the days when the weather isn't quite cooperating. Just like you wouldn't build a skyscraper to withstand average winds, right? We need to make sure the grid is resilient to even some of the most extremes. And so for those who don't know, NERC, the North American Electric Reliability Corporation, we're a nonprofit international authority, regulatory authority. We are the ERO for North America. We have oversight with FERC and of course similar government authorities in Canada. We really have the mission of doing two main things. One, develop and enforcing our reliability standards, but then also doing assessments. And the assessment I wanted to talk to you today is our summer reliability assessment. And we published this report a couple weeks ago, and we've been doing this for quite some time. About 50 years, we've been developing these seasonal long-term assessments. But what we found in this summer, as we've similarly found it in recent assessments, is an absolute step change in the risk environment surrounding reliability and security. And so as the industry continues to face a lot of challenges, the resource mix changes we talked about, more extreme weather impacting the system, the onset of more distributed energy and inverter-based resources, we're really seeing a really step change in the risk environment. And so our most recent summer assessment that I'll kind of get into provides kind of that sobering view of the potential risk. It's not necessarily a prediction. We live in, and especially the system is a probabilistic system. And so, but it is a risk assessment, meaning, we don't necessarily predict that there's going to be blackouts, but again, the risk profile, the probability that we will have more issues is increasing, and it's underlying, and you can really see it in the data. And this current outlook that I'm going to share with you really represents, it's driven by a couple things. One is the conventional generation retirements that we continue to see, the increase in the forecast peak demand that we see, and also, while we're good under generally normal conditions, wide area heat waves are really the thing that are going to challenge both the eastern and the western interconnections. Okay, let's go to the next slide. And of course, recent events we've seen in the summer and winter, both summer and winter, clearly show the system's closer to its edge, and so we need to do more to bolster that resilience. And we've been accustomed to counting on our neighbors, especially neighbors with hefty margins in support or during extreme times. But again, that wide area heat wave can really substantially hamper that ability. So let me talk a little bit about the key findings. And I guess it's first and foremost, what the grid transformation will enforce, the retirement of resources remains highly concerning. We have all areas that have adequate resources for summer demand. So they all meet the reliability criteria, which is kind of like saying we've all met the code, right? We've all met the interconnection requirements, but again, the risk profile is increasing. We've brought, what's aided that though is some 20 gigawatts of solar capacity that's been added since last summer. That's actually helped the system. We've been able to bring solar capacity online pretty quickly. It's very difficult to bring in conventional resources. We're not building a lot of natural gas, and nuclear is not being built, and certainly not coal. And so solar has actually provided that ability to be able to be brought on, and we've seen 20 gigawatts of that show up. That should help. Of course, some battery growth as well. 2 gigawatts of batteries were built in California, and there's been a lot of commitments to demand side resources, demand response programs, and even some success of some emergency programs that we've seen even in California as well. We also want to talk about the operators facing during these extreme risks. So this is really the challenge that we have. As a retired generation, there's just a lot less margin to go around. Supply transfers are really the thing that are at risk during heat events. It's the thing that we've most recently been legislatively charged to study. If you all are following the recent Fiscal Responsibility Act that charges NERC to conduct transfer studies, it's because transferring from neighbors is something that we see as diminishing, and so under these hot weather events, something that we really need to keep a close eye on. The last key takeaway is the monitoring of our supply chain issues can really affect our summer preparations. A lot of entities have reported disruption to routine preseason maintenance activities, equipment not being available. That can continue to higher forced outage rates that we've seen for generators and our transmission equipment. Also delays due to labor, material, equipment shortages. Those are all things that are common now. And so in areas that are certainly expecting these types of resources, batteries and solar, the West and Texas, delays could exacerbate some of the risks that we've shown. Let's go to the next slide. I think this is the most kind of telling ability to kind of show where we see the risks. We rate all of our 20 assessment areas on a low, elevated, or high risk scale. Again, last year we saw about 6.5 gigawatts of retirements. Continue to see retirements of conventional units, and again, this is really hampers reliability if that replacement capacity isn't of comparable reliability. And so while there's an abundant amount of energy for peak demand in all these areas and across the West, the West does face some challenges in meeting high demand in the evening as the solar output diminishes, right? So this is kind of that changing dynamic, right? Where we've used to be worried about electricity demand during peak conditions when all the air conditioners online and all the factories are going, high commercial output. But really some of the challenges are actually at nighttime when there's not a lot of solar. So that's really becomes the area we want to understand, and that's leading to greater risk. I'm glad that also the prior panel talked a little bit about the recent rainfall and snowpack in the West helping hydro generation. It could, but it's certainly too soon to know for sure. The water, one of the challenges one of the understandings that we understand through the risk assessment of the generation system, the hydro generation system is the West, is that the water that we're seeing may not go to the dams that we need it from an electricity perspective. So it's a risk factor that we look at. Also in SPP and MISO, wind energy is the key to meeting the summer peak demand. So we need wind to really be there. In Ontario, we see some planned nuclear outages. CERC Central, which is the TVA area, we see tighter summer conditions because of higher forecasted demand. In New England, we have less capacity in the summer as a result of retirements and fewer imports. That can lead to some use of conservative operating procedures and some risk of shortfalls, again, under extreme conditions. And in ERCOT, we talked about solar resources coming on, 4 gigawatts in solar out of the 20 that came on, and helping that area kind of get out of the high risk and get into more of the elevated risk, which is still not where we want to be for reliability. So the next slide. So really quick, some other reliability issues we're tracking. Some lower inventories of replacement distribution transformers. We see could slow restoration efforts. These aren't bulk system high voltage transformers, but at the distribution level, if you don't have the right type of distribution transformers during restoration efforts, i.e. hurricanes, that can hamper restoration efforts, which we've been doing as an industry very, very well. Natural gas and coal supply delivery is also being monitored. We have a general challenge with integrating inverters, solar voltaic inverters. We're starting to see some leading indicators about some challenges with integrating large amounts of these inverters. A lot of industry effort. So that's something for the system and transmission operators to better understand. And of course, right now we need to prepare for the environmental rules, not only kind of in real time, and whether or not there's opportunities to bring in, advanced permitting or advanced waivers in place for, when areas get in a pinch. But we're also looking longer term here. I think that which is important. Let's go to the last slide, which is really just some recommendations, and I kind of highlighted some ones for this audience that I think are pretty important. Of course, the operators, and one of the reasons why we put out this report is to inform all the operators around what their neighbors' plans are and understanding these supply shortfalls. So certainly for the operators to understand where they are in terms of the whole interconnected system. But the next one, operators and load serving entities develop coordinated procedures for demand reduction appeals. I think this one's really, really important. If there isn't a coordination between efforts for demand reduction appeals, so these are public appeals or emergency text messages or warnings, we really need to kind of coordinate these with the system operators and the local utilities. Otherwise, you can have some challenges there. So real good coordination between those, your emergency offices as well as with the utility and the wider area transmission operators. The third, the generator owners. Again, I talked a little bit about the solar PV issues. This one's really directed towards these solar PV owners. And then the last one, the regulators industry preparing for managing emergent requests for environmental waivers. We see this every year when there's large heat waves where it's either cooling water or air permits or whatever it might be. And during pinches, during emergency conditions, these resources are absolutely needed. And so we want to make sure of the ability to do that and to kind of get in front of that. So we're not last minute trying to get waivers and last minute decisions. We want to have processes in place to make sure those are seamless would be the best way forward. So I'll kind of end there, see if there's, I don't know if there's any questions, but we'll just turn to the last slide and thank everybody for your attention. Again, it's not a prediction of reliability, but an assessment of the risks. And really we need to really be aware that the underlying risks that we face and the probabilities of outages is increasing. Even though we have some of the highest reliability we've ever seen, we want to keep it there because that's what really charges a system that's socio-economic and also environmental friendly. Thank you, everybody.
Thank you very much. And I'll give this moment for folks to put a question in the chat if they certainly have one for them. I'll start with, Winter Storm Elliott, even though that was winter versus summer. One of the things I think that elevated for us, certainly here in the Valley with TVA, is it part of why we ended up in a more curtailment atmosphere was just what you were saying. Our neighbors didn't have power that we could get it from. And so is part of the elevated risk we're seeing in every market, because it's, I guess I sort of, my layman's term is I sort of attribute it to, it's almost like a credit crunch, and that there's less available for everybody to spare. So that means there's a little more risk for each region because there isn't the margin that I can borrow from TVA or I can borrow from MISO to get it out there. And that seems to be part of why we're seeing a little bit more elevated risk overall.
Yeah, it's a nice way to look at it. A lot of these analogies can fit that. You know, we can take care of, you know, one credit failure, right, or one failed bank, or one, you know, we have these systems built in to support that. But when kind of everybody is kind of tight on their internal resources, and then when they have these heat events, and they've always have counted on their neighbors with success in the past, you know, everyone's also feeling that pinch and is unable to share when, you know, at that exact moment, right? And which is the critical piece, because we always have to balance supply and demand. We can't store it for later. And so getting all that at one point is really the area we see the most risk.
Are there other things that, as the state energy offices, because we do, you know, these are private assets that we end up helping coordinate, are there other things? I think touching on the communications piece was really great as well, because that became part of what we saw during that didn't go well for all of us, as it wasn't coordinated well. And so I think one of the roles energy offices could do is to help coordinate those communications, or at least amplify the ones that come from our power generators, and helping do that. Are there, besides the California example, because I think that's a great one of how they managed to avoid rolling blackouts by curtailing themselves, basically, and reducing voluntary reductions first. Is there another example of that's worked in the summer that is particularly good to point to?
Yeah, there's the emergency ones, but even before you get there, which is kind of more of the demand response, demand side management, energy shifting type programs. There are tariff type things depending on where you are from a regulatory or a perspective, where you can kind of design programs so they're using energy at different times. You know, so there's a couple of things you can do, you know, even before you get into that emergency. But one of the major things is coordinating that. So that so the system operators can understand how the system might change because of a text message, and because they can be so effective. And so, yeah, really understand the power of that.
Yeah, it's hard to underestimate the power of just a text message these days. I don't see any other questions in the chat. And so with that, I'll say thank you very much for reviewing this assessment. It's always a great product, and something that I've come to count on each year to sort of get a good understanding of what's going on in other regions as well, because like all things energy, we're all interconnected, even when we don't want to be sometimes. But so that's partly why the wildfire impacts and other stuff will have an impact on generation and needs. And so that's partly why having this awareness and is so important for the states. Thank you very much.
Thanks, Ben.
And with that, we will turn to Citibank. And Ed Morris is the managing director, the global head of commodity research at Citigroup, an old friend to NASEO, and certainly will help us. He is going to navigate his own slides. That's right, Ed. All right, that looks like they've stopped sharing. So I think, Ed, you can start sharing now. Yes, there we go. We can see your screen.
Perfect.
Go ahead. Thank you.
I can't see the screen, however, but I'm glad you can see it. Okay, so you can see the screen.
We can see the screen. The slides are not taking up your full screen, though.
Well, that's unfortunate, because I can't do anything about it. That's going to be fairly unfortunate. Maybe we'll, there's one slide in particular that I have to share. So if we go back to you're sharing my slides, I will just talk about the one that I'm not sharing. So the title of my deck is really a lot milder and less volatile this summer than 2021 or 2022. You know, we've seen in, I am trying to share my slides unless somebody, I guess you can't see them, but I'm doing my best to put it up.
We can see them. It's just the PowerPoint window is sort of minimized. So if they could make that full screen, it would probably share them all to a readable size.
I wish I knew how to do that. I'm at a loss. Sorry about that.
Okay.
Nope, doesn't work. So I'll stop sharing. And you can, go back to my slides and I'll just talk to them. I think that this summer looks to be much less painful for consumers and businesses than what we've seen in the past. The next slide, please. Summers 2021 and 22 were really unbelievably exceptional. They reflected very severe conditions across the planet. They reflected a globalization of very severe weather conditions that we've never seen before. Nothing was isolated from one region to another. They involved weather issues and tectonic shifts, especially associated with Russia and Ukraine. And I think there's been a lot of change since 2022 in terms of making the outlook for this summer a lot less severe than the outlook was for last year, the year before. And there are 7 points that I want to make on this. And to be sure, we've had some of them already noted with a more moderated set of weather conditions by the widespread nature of El Nino conditions around the world. But there are 7 good reasons for less pain. And I think, going back to what we heard from NERC and their effort to focus on reliability, resilience, and security, the most critical thing about grid performance really is reliability, resilience, and I'd say redundancy. Redundancy for summer fuel conditions, and along with that, greater affordability. And I think there's no comparison, not just because of the relatively good news that we heard on John's presentation, but also because the conditions are now so different with respect to the resilience issues and the redundancy issues. We've learned an awful lot about grid performance in the last 2 years, and I'll talk about some of those things in a minute. But if we just go back to 2021, we had a lot of heat, a lot of drought, and no wind in a bunch of parts of the planet, a bunch of the parts of the northern hemisphere. We had loss of hydro in the right places in China, in the northwestern parts of the US, in both Northern Europe and in Southern Europe. And because of a lack of really the redundancy that provides resilience and reliability of grid performance, we ran out of fuels. And the result was, from having gotten rid of thermal power too quickly in too many parts of the world, and that included both China and in Europe, we had an escalation demand that was global in proportion for natural gas via LNG, and LNG prices went up. They went up tremendously. They went up from the $2 range to the $5 range in the US between winter and summer, but hit an actually exceptional part in early February when there was no wind in Texas, and there were freeze-offs in ERCOT, and we had spot natural gas going from $240 per million BTUs to $880, and in Oklahoma to $1,100. And there were similar impacts in the summer of 2021 across the planet when it came to natural gas, because it was the only thing available to fill in for the difference. But we are not going to see that in all likelihood in summer 23. Largely, hydropower is back. It's back in spades in Europe, more so than we thought it might be in the US. And we don't know what's going to happen in China. But by and large, hydropower is back, relieving pressure on fossil fuels. The third big point is we had 2 massive disruptions in 2021 that are not going to be repeated in all likelihood. They're tectonic in nature. They're geopolitical in nature. The year started with the Russian invasion of Ukraine. That led to European companies and European people, and then finally European governments deciding that they were not going to import oil from Russia. They imported 80% of Russia's exports. Russia started the year as the world's largest exporter of oil and gas, and the result was that by the end of the year they were exporting 20% to Europe, 80% to Asia. beginning of the year, 80% to Europe and 20% to Asia. It led to a bidding up of prices. We would not have had $125 oil in March of last year had it not been for that bidding up process that had to work itself out through dislocations in the market. And similarly, we had dislocations in natural gas, massive ones. At least in the terms of oil, that's fungible. You could move it instead of to Europe. Russian oil could go to the Far East. It was more costly, sold at a discount there as a result of the costly nature of moving it. And they were Atlantic Basin oil bid up. But on the natural gas side, there was nothing to replace the 15 BCF a day of natural gas that Russia was exporting to Europe, other than bidding up the price in order to ration it. And we're not seeing that likely this year. We're seeing, to be sure, a much looser natural gas market, as I'll explain in a minute. Natural gas prices escalated and then collapsed to levels that we would never really expect. We had unbelievably unreasonably high diesel and gasoline prices. We think that those high prices have dwindled. And really the natural cause of this was fuel switching from natural gas, which became very expensive, to diesel, which became expensive. We had 1.5 million barrels a day of fuel switching, mostly in Asia, 500,000 in China, switching the diesel fleet from natural gas to diesel, where it's the double capacity to use dual fuels. We had another 1 million barrels a day of switching in generation. We had a loss of around 700,000 barrels a day of European diesel make, and we had refineries that were closing. And now we have all of that reversed. We've got the diesel back, not in the power gen system, but for trucks. We have 2 million barrels a day of new refining capacity as between China and the Middle East, with another 1.5 million barrels a day coming into the market starting now, between now and the end of the year. So from a refining perspective, we've got much more refining capacity, and we see positive gasoline demand growth, but it's disappointing in terms of demand. And here's the chart I don't have in this deck, the most important one. Our price forecasts are really for a very range-bound market, as opposed to a range of $70 to $125 for oil last year, and in Europe, a range of between $10 and $200 per million BTUs at times in different parts of Europe. This year, we're looking at WTI really in a $70 range every quarter of the year, even with things that could happen in the summertime, as I'll explain in a minute. So yeah, a range from 70 to 80 at an average price for a quarter is not like a range that we saw last year under most conditions. And on natural gas, Henry Hub, we think is going to be in the $2 range. It could possibly go to a $1 range at times because we're not shutting in enough natural gas fast enough. We're producing more natural gas. We're not having the relief of LNG exports growing again as we become the largest LNG exporter until late in 2024. And Europe, instead of seeing high natural gas prices, is likely to see natural gas falling in the third quarter to around $4 per million BTUs from the 16, 17 that it was in the first quarter and the 36 that it was in the fourth quarter of last year, and similarly in Asia as well. So we're seeing even thermal coal prices falling, and we expect them to continue to fall. So the range of prices is much milder than we saw earlier. The next slide is a look briefly at gasoline. We think that, as you see in the upper left, the one difficulty with the gasoline market is that gasoline inventories are very low. The good news is that gasoline demand is not very high. We've had, and you can see a little bit of it on the lower right, we've had basically no new gasoline demand season. We had on high frequency data over Memorial Day about 1 million barrels a day less demand than a year ago. And even in the period after Memorial Day, things spiked up a bit, but then they went down. And year-on-year growth is not really remarkable. And we don't think it's going to be remarkable partly because of the nature of retirements in the US, demographics of work, people driving less for all kinds of reasons, demographics being one of them, and then on a global basis, the EV displacement of global oil and oil demand, which we see accelerating, and we're seeing, gasoline reaching globally its last hurrah, and that's a controversial subject, but we think that this is very logical and likely to happen. The next slide is a look on diesel. Diesel, just like gasoline, we're seeing on the upper left, really limited diesel inventories. Diesel inventories in Russia are high enough, and they're supplying the market. And we're seeing a new arrangement of diesel flows, so that with all of the Russian crude that's now going to India and China, we're seeing refinery runs up. We're seeing them actually exporting diesel from China and from India into Europe. And we're seeing both Europe, the JKM LNG, moving back to below diesel equivalent prices. And we're seeing diesel cracks collapsing, which is a sign that we are seeing less diesel demand. And actually, structurally, we're seeing it. You can see it in two ways. Structurally, one way is on the bottom right. We're not seeing trade volumes grow. We're seeing deglobalization actually on the trade side. And that means both, not just in China, but in Europe and the US, where trade volumes are down. And they'll be down because of the homing in of supply chains that are now national policy in the US and in Europe, and because of the Chinese policy of limiting vulnerability on the export side. So we're seeing the need for diesel to move goods to and from ports also falling on a structural basis as well as a long-term basis. On the next slide, we could also see, the new change in European gas demand. Look at the lower left. This is industrial demand for natural gas in the main industrial countries. In Europe, it's not only not recovering, but it's down. And we're seeing industrial, energy-intensive industrial facilities moving out of Europe, moving partly into the United States. And we're not going to see more than 15% less demand for industrial gas in Europe than we have historically in the summer. That's now evolving, while at the same time, look what's happened to hydropower, down from a low below normal range to now being up at the midpoint range with plenty of rain in both the Mediterranean and in Northern Europe. So we're not expecting to see the kind of disruptions to supply that we saw before. If we look at the next slide, and I'm getting close to the end of my remarks, weather does remain the main risk. El Nino may help by the wind shear that could keep hurricanes out of the Gulf of Mexico. We're looking at temperature outlook probabilistically being higher in China than it is normally, but potentially lower in the United States than it is normally, and it may well be associated with a dry environment. But we do think that weather and geopolitics are the main risks, and they become a significant risk for the reason that I will allude to on the last slide that I want to go through, and that's what's really happened in the United States. There's a lot of controversy over U.S. oil production. We're seeing one after another prediction that U.S. crude production is on the verge of collapsing. But the U.S. has become the most critical crude and product and gas hub in the world. And this is where the danger comes in for the world as a whole as part of a hurricane season. You can see on the upper left chart that PADD 3 crude production is way up. It's well above 9 million barrels a day. It's about 750,000 barrels a day higher just in PADD 3 than it was a year ago. In the U.S. as a whole, crude oil production is about 1 million barrels a day higher than it was a year ago, but as I said, concentrated in PADD 3. Demand, by the way, is not up. demand is down year on year in virtually every product suite, particularly aviation fuels. It's down in diesel. It's mildly up in gasoline year to date on a year-on-year basis. And we don't expect it to be shooting up. And the result of all of this is look at crude oil and petroleum product exports out of PAD 3, but particularly crude oil exports reaching close to 5 million barrels a day at times. If we look at combined crude oil and petroleum products out of PAD 3, they're way up. Not only are they way up out of PAD 3, but the US as a whole has become, if we look at liquids production, and the last month we have data for is March. Notably, March crude oil production was 12.7 million barrels a day in the final data. And the weekly data was 12.2 million barrels a day. So we had a 500,000 barrel a day correction of what we thought we had in the weeklies when we got final monthly data for the month of March on the last day of May. We also got final data for crude oil and petroleum product demand, exports. And the number is an astonishing 13.3 million barrels a day for the month of March. And when we look at total product supplied, not just crude oil, but also natural gas liquids and biofuels and refinery efficiency gains, the US in the month of March, while not reaching its highest level ever of crude of 13.1, did hit the 12.7 mark. We think it'll hit 13.2 by the end of the year, but 12.1 million barrels a day of liquid supply is the highest monthly supply that any country has ever provided. So the US has become critical, and it's also now the largest source of LNG for the planet. When we think of US LNG exports, they're now, and this is a revolution since the year before the pandemic hit, we're now exporting some 14.5 to 15 BCF a day. We'll be increasing above that by the time we get to 2024. But all of this says that if we have not one, but two, or even three, category 3, 4, or 5 hurricanes that do hit the Gulf of Mexico and do hit PAD 3, we could have outages on LNG, on products, and on crude that the world has become dependent upon. We don't think it'll last long, but our last big hurricane season had shutdowns for 6 months. So I'll leave it at that. We have a forecast for a mild summer, and we're hopeful that that's going to happen. Back to you, Ben.
All right. Thank you very much, Ed, for the wonderful outlook and insight. As always, I'm glad we got the slides working. I know there's been a lot of back and forth and changing with that, but do appreciate you getting those and working together to get that and giving us such a good outlook, because it's sometimes, I think, easy to not realize that the market impacts in Asia and other parts of the world do have something that will impact what's going on here. But for time's sake, because we do have a hard stop, and I need to get it over to CESER, our wonderful colleagues there. So we're gonna end that there. And thank you very much, Ed, for joining us as usual, and appreciate all that went into getting that excellent brief together for us, and appreciate your time.
Thanks for having
So
me.
with that, I will turn it over to the CESER office to then basically just direct what's going to happen next. And I think Matt, who is going to is that going to be Matt or Jennifer? You want to start us out?
Yep, then we've got Brandy. She's going to start us. Hold on.
Oh, we got echoes. Brandy, you're going to start us off?
Goodbye.
All right.
How does it sound now?
Excellent. There we go. That sounds perfect.
Ben, you're muted, but I think we're okay.
Get a thumbs up.
Okay.
Great. So I know we got a little bit of time left. We'll try to make this very quick. If we jump on the next slide, just for any of you that are not familiar, it's the Office of Cybersecurity, Energy Security, and Emergency Response. We lead the nation's effort to enhance the security and resilience of the energy structure against all threats and hazards. Obviously, today we're focused on weather, but we're very concerned on the cyber side and physical threats to work with you all steady state and during response, which you'll actually see on the next slide. So you'll get these slides to go over. But just a reminder, some of our authorities, we are the Sector Risk Management Agency. And we also have the ESF 12 authority. Under SRMA, as you may hear us all call it, we have all of our acronyms. We engage the energy sector, public and private partners to, again, back to our mission, promote the security and resilience of the nation's energy sector. And then during ESF 12, we have kind of a coordinating role to help smooth along the restoration and recovery process. I just want to share this though, because we do work with a lot of you in steady state around emergency preparedness with policy. We also do a lot of R&D, and then we have the ESF 12, which we get activated under the National Response Framework. So within CESER, it's a very broad scope, but we have teams that are working together to ensure that what we learn during a response or what we learn during an exercise kind of gets looped back into that bigger picture. And I did want to say hi from the entire team here. We're going to pass the ball around, but just thanks for inviting us, and appreciate your time today.
Yeah, absolutely. I'm Megan Levy. I know most of you new to the CESER team, but I just wanted to, if we could go to the next slide, please. Brandy mentioned regional coordination. I just want to, we always like to talk about the Energy Emergency Assurance Coordinators agreement between CESER, NASEO, NERC, NGA, and the National Emergency Management Association, which really enables bi-directional information sharing, which after we've been talking about all the upcoming threats and the natural threat environment, it's really important that we have that. And most of you received a EEIC brief for the month of May from us, which is TLP Amber earlier today. So these are the goals of the program, and we send that brief out every month to provide the credible, accurate, timely information for you. So with that, because I know we're running short on time, I want to hand it over to Matt Tarduano for the next slide.
Yeah, thanks so much. So as Brandy mentioned, DOE is the coordinating agency for Emergency Support Function 12 under the National Response Framework. That is what people envision as the large FEMA response during a natural hazard or other disaster situation. And there are 15 emergency support functions, each assigned to different agencies to manage. Emergency Support Function 12 is the energy sector. Many of you support the state Emergency Support Function 12 efforts, and we all try to work together. During a major situation like a hurricane, we will deploy responders to state emergency operations centers, FEMA regional response coordination centers, and the National Response Coordination Center here in Washington, D.C., along with a team that gets activated at DOE headquarters to help coordinate all of our efforts and all of our deployed responders out in the field. We do have a subset of responders that we call our catastrophic incident response team. These are responders that have the most experience and come from generally the power marketing administrations or other areas in the department where they bring technical capabilities and subject matter expertise. We have 3 of those responders deployed right now to Guam as part of our ongoing response to Typhoon Mawar. And we've had responders out there deployed since before the typhoon even made landfall a couple of weeks ago. The department, we also coordinate in steady state. We're continuously monitoring for any incidents that might be impacting or potentially impacting the energy sector. And over the years, most of the department's emergency authorities relevant to the energy sector have been consolidated in CESER. And so we help coordinate those when they are needed. Things like orders under Section 202C of the Federal Power Act, which can be used to mandate interconnections or to run power plants when they might not otherwise be available. And we often see these when there are potential energy shortages, things including ones that were issued very quickly on Christmas Eve for the Mid-Atlantic this past December, as well as Texas in December. We've issued several for California over the years and other parts of the country when those types of things are needed. We also spend a lot of time on fuel, and I'm going to turn it over to my colleague, Jennifer Matthews, who's just going to take you through a quick fuel supply situation or the current status of the fuel situation. We work very closely with our colleagues in the Energy Information Administration and constantly looking at inventories. Obviously, when we had this conversation last year, fuel was a major concern, and we, we're very particularly worried about how a disruption on the Gulf Coast or to pipelines could impact fuel supply availability elsewhere. We are continuing to monitor that. We are, continuing to review that data fairly frequently. But overall, as you're going to hear from Jen, we are not as quite as concerned as we were last year. We don't feel that we are as in precarious of a situation, but it is something that still needs to be monitored. And finally, before I kick it off to kick it over to Jen, when we are activated and there is an incident that needs to be coordinated, in addition to our efforts with our SLTT partners, we're also convening unity of effort and unity of message calls with the Electricity Subsector Coordinating Council and the Oil and Natural Gas Subsector Coordinating Council for those efforts and for making sure that our activities are aligned with our industry partners. But at this point, I'm going to kick it over to Jen, who's just going to run through some quick fuel status.
Yeah, thanks, Matt. Hi, I'm Jen Matthews, and I'm just going to give a brief summer fuels overview for the U.S. primarily coming from the EIA short-term energy outlook. So next slide, please. Although gasoline demand still has not hit pre-COVID levels, the EIA short-term energy outlook anticipates slightly higher consumption this summer for gasoline compared to last summer, as you can see on this graph. Now, gasoline prices are expected to average about 20% lower than last summer's prices. The average regular gasoline price is anticipated to drop from $3.60 per gallon to $3.30 per gallon by September. And this is primarily driven by lower crude oil prices and lower refinery margins for gasoline as compared to last year. Next slide, please. So U.S. refinery runs are forecast to be the highest level since 2019, coming from recent refinery expansions, most notably at the Beaumont refinery. We're also hitting the end of refinery maintenance season right now, which will increase gasoline production. Margins remain high enough to incentivize running crude, and so far gasoline crack spreads, which is the difference between the wholesale price of gasoline and crude oil, have been at or above the 2018 to 2022 average during the second quarter, primarily in response to low gasoline inventories. Demand and gasoline supply are both up a little bit, keeping the balance fairly tight this summer. The price spread between gasoline and diesel has shifted in the last few months to favor gasoline, shown in the blue on the graph. And then in yellow, distillate yields have been trending downwards in response to that, and gasoline yields could continue upward to produce additional gasoline this summer without increasing crude runs. Next slide. So gasoline imports for the summer are anticipated to be at a similar level to last summer. You can see on the graph here, we're just coming into the summer season and around the same level as last year, but this really could change based on the price differential or the arbitrage between Europe and New York Harbor. Most of these imports of gasoline are primarily headed into the East Coast region. Next slide, please. Okay, so here you can see the regional gasoline stocks as of May 26th. Gasoline inventories remain below the 5-year average across the US, very similar to where levels were in the summer of 2022. Notably, all the subregions of PAD 1 and in PAD 2 are at double-digit percentages below average. And really this means there's less buffer when an extreme weather event, like a hurricane, impacts production or even supply infrastructure like pipelines. Next slide, please. Similarly, distillate inventories are below the 5-year seasonal average across the US as well, and distillate inventories are expected to remain fairly low across the US through the end of this DO forecast. Next slide, please. So turning to natural gas, US natural gas storage inventories have been quite higher than average since the beginning of 2023, now at about 15% above the 5-year average. This was because of mild weather over the winter, producing weak demand and widening that surplus. The EIA STO predicts the natural gas inventories will build through the summer season, but at a lower rate than typical, primarily due to high summer demand expected. The inventory level is expected to land just above the 5-year average, around 4% above at the end of October. And higher demand is primarily being driven by electric power generation that's expected as a result of the relatively low gas prices, lower coal-fired generation this summer, and just warmer than normal expected weather forecasts. LNG exports are expected to be higher this year than last, with a new export facility that came online in late 2022, as well as Freeport LNG, which came back online in the last few months. But this demand is primarily anticipated to be offset by increased gas production, which hit record levels in April. Next slide, please. Oh, and here's the contact information for the CESER SLTT team. Thank you guys for the time, and back over to you, Ben.
Thank you for all our staff at CESER and Jennifer for that quick rundown of EIA. I'm certainly sorry that they couldn't join us, but you did an excellent job of presenting that. As a reminder, I said that about the EEAC list earlier. Part of why you want to sign up with that is DOE's monthly briefing came out. That's a great way to maintain good awareness of similar information that Jennifer just went over. Review that. I use it as a great point to send that up, send that to key people, both in the governor's office and others, and that gives me that monthly touch point to update staff that may be involved in an energy emergency, and kind of keeps them, if they want to read it and learn a little bit more about energy, it's a good way, and a lot of times it will spur back a question and some good dialogue between us. And thank you, CESER, for all that you do to help us. I'm glad to hear, figured y'all had some folks in Guam. We certainly are keeping them in our thoughts as they're still responding to that devastating typhoon. I almost said hurricane, but it's the other side of the world, so that's a typhoon, not a hurricane. With that, are there any other questions for CESER? One of the things, CESER did put the link to the program and where you can sign up for it. I also had Sarah put in the chat a link to the wonderful energy security action list. For those of you that are newer to energy security, that certainly is a good anchor point for you to of some things to sort of start, when you're trying to get your head around all of this, which is nearly impossible. That's a good anchor to get you started, and certainly reach out to all of CESER staff if you have questions or you need help with something. Same with NASEO staff as well. That's what we're here for. Is no one is, energy runs across all sectors as far as the impacts it have when there are disturbances in it, and our government and public and even private stakeholders rely on us to help them find those answers even when we don't know them. So that's part of the wonderful network that you have here, and I appreciate all of our speakers today and taking the time out. I know it's a tight briefing with so much more. We could do 2 hours on just one of these topics easily for all the information, and I think it goes without saying, you make it look simple in all the slides that you present, but I know that it's distilling an incredible amount of information into a very small amount of space and slides, and I certainly appreciate that and taking the time to brief us with that and everything else. With that, I'll turn it back over to NASEO if they have anything else to close out.
Thank you, Ben. No, just to say a final thank you to you as well for moderating this. I know this is one of the events that you like and we all like, and you're doing an excellent job shepherding through all these tight presentations and keeping us on time and on target. So with that, it's 5 p.m. Eastern, and I just want to thank you, the speakers, and DOE CESER for the support of this, and thank you all for attending. Have a good day.
Thanks, everyone.